So this present video is in continuation with my earlier video on general organic chemistry, and in this present video I am going to cover on this topic of Tetracovalency of carbon. So basically 2 points I will cover. Carbon is a tetravalent. It forms 4 bonds, and second is the covalent bonds formed by carbon atom. Covalency of carbon atom. So let's start. So carbon atom, we know atomic number is 6. So the electronic configuration is 2, 4. So in the outermost shell of carbon atom, it is having 4 number of electrons. And we know very well, in order to stabilize itself, any atom needs to complete its octet. So in this case, if carbon gets 4 more electrons, so then its octet will be complete. But energetically, it is very difficult for carbon to either gain or lose 4 electrons to complete its octet. So neither it can gain 4 more electrons nor it can lose 4 electrons. So how does it stabilize itself? So carbon atom always combines with other atoms by mutual sharing of electrons. So in case of carbon atom, it combines with the other atom by mutual sharing of electrons. And these type of bonds are called the covalent bonds. So in case of carbon, it completes its octet by combining with the other atoms by mutual sharing of electrons, by forming the covalent bonds. So as all organic compounds contain carbon as the essential element, therefore the nature of chemical bonding in organic compounds is always covalent. So all the organic compounds are covalent in nature. So thus carbon is always tetravalent, that is, it forms 4 covalent bonds with the other atoms. So carbon is tetravalent. So now I will explain this with the help of the example of methane. So methane is written like this, CH4, and it can also be written like this. Center carbon is there and it is attached with the 4 hydrogen atom by a single bond. So this structure we can represent here also. So here center carbon atom is there, and in the outermost of carbon atom, outermost shell of carbon atom, 4 electrons are there, which I have shown with the red dots, 1, 2, 3, 4. And to complete its octet, carbon atom needs 4 more electrons. And then these 4 hydrogen atoms, and we know hydrogen has only 1 electron, which I have shown with this cross. So hydrogen needs 1 more electron to stabilize itself. So for this hydrogen shares 1 electron of the outermost shell of the carbon atom. So here I have shown it like this. So this hydrogen is sharing this 1 electron of the carbon atom. So in this way, hydrogen is able to stabilize itself by having the 2 electrons. In the same way, all other 3 hydrogen atoms also stabilize itself by sharing 1 electron with the carbon atom. So then now we can come to the carbon atom. So as carbon atom needs 4 more electrons to complete its octet. So how it happens? So this carbon atom shares all the 4 electrons from all the 4 hydrogen atoms. So one electron from each hydrogen atom. So in this way, it can be shown like this. So in this way, carbon is able to complete its octet by having the 8 electrons. So this way, like we can say, if this is the one single bond, one single bond, one single bond, and one single bond. So in this methane molecule, there is a single covalent bond which is formed by the sharing of a one pair of electrons between carbon and hydrogen atom. So this is the single covalent bond. So we can understand with the help of the examples of oxygen and nitrogen about the double covalent and the triple covalent bond also. So here oxygen I have taken. So oxygen, we know oxygen atom has the atomic number 8 and the outermost shell and its electronic configuration is 2,6. Outermost shell is having the 6 electrons. So for both these oxygen atom, we can write like this. Oxygen is having the 6 electrons in the outermost shell. 1, 2, 3, 4, 5, 6. Same with this oxygen atom also. So then oxygen atom needs 2 more electrons to complete its octet. So how will it happen? So this oxygen atom will share these 2 electrons from the other oxygen atom. So in this way, its octet will be complete. In the same way, the another oxygen atom also shares the 2 electrons from this oxygen and its octet is also complete. So because there is a sharing of 2 pair of electrons in oxygen, so that is why it is represented by this 2 lines and this is called the double bond. So this is oxygen is the example of having the double covalent bond. So now we can see nitrogen N2 and the atomic number of nitrogen is 7. Electronic configuration is 2, 5. Outermost shell, it is having the 5 electrons. So here I have shown these outermost shell 5 electrons. 1, 2, 3, 4, 5. Same here for this nitrogen atom. So this nitrogen atom needs 3 more electrons to complete its octet. So how will it happen? By sharing this nitrogen will share the 3 electrons from the another nitrogen atom. In the same way, this nitrogen atom will share the 3 electrons from the another nitrogen atom. So in this way, octet is complete for both the nitrogen atoms and this is the sharing of the 3 pair of electrons between the 2 nitrogen atoms and it is shown like this. Three bonds are there between 2 nitrogen atoms and it is called the covalent triple bond. So this is how we can understand about the covalent bond which is formed by the mutual sharing of the electron pairs. So till now, whatever we have discussed, these structures do not reveal the spatial orientation of these bonds, whether they are planar or non-planar. So from these structures, we cannot understand anything about the spatial orientation. So first time Van Hoff and Liebel predicted that the 4 bonds of carbon atom are directed towards the 4 corners of a regular tetrahedron and it means that the angle between any 2 adjacent bonds in methane is 109 degree and 28 minutes. So this I will explain it with the help of these 2 pictures. So this is the diagram of a tetrahedron. So we can see here 4 corners are there, 1, 2, 3, 4. And this is the another picture which is showing the structure of the methane molecule CH4. So as I have just now told, according to von Hoff, the 4 bonds in methane are directed towards the 4 corners of the tetrahedron. So here we can see center carbon atom is written and the 4 valencies of carbon are directed towards the 4 corners of the tetrahedron. And the angle between the 2 adjacent bonds is this 109 degree and 28 minutes. So this was a discovery for which von Hoff was awarded the first Nobel Prize in Chemistry in 1901, and even he was called the father of organic chemistry. So now the question is, how can we do the 3D representation of organic molecules on paper? So 3-dimensional representation of organic molecules. So for this purpose we do it by the wedge and dash representation of methane. So this is the 3D representation of methane by wedge and dash representation. So in this this way to represent the organic molecule, it is done by using certain conventions. So here we use this type of solid wedge bond, solid wedge and the dashed wedge. So let us understand what are these. So the thick lines, the thick solid line, which we also call solid wedge, this indicates a bond lying above the plane of paper. Means that this bond, this CH bond, which is a solid wedge, it means that this bond is lying above the plane of paper and projecting towards the observer. And this is the dashed wedge, and this is used to represent a bond. This is used to represent a bond which is lying below the plane of paper. Now means that this bond, this dashed wedge is projecting away from the observer. So, and one more point is there to remember that these wedges are used in such a way, in both these cases, wedges are used in such a way that the broad end, this broad end is towards the observer. So in this case, solid wedge, this broad end is towards the observer. And in this case, dashed wedge, this solid edge is towards the observer. And the other 2 bonds, this one and this one. So these are, if they are represented by a ordinary normal line, it means both these bonds are lying in the plane of paper. So once again I will repeat. So this 3D representation is done with the help of the wedge and dash formula, and here I have written for the methane molecule. So this is called the solid wedge, means that this bond is lying above the plane of paper towards the observer, and this dashed wedge means that this bond is lying below the plane of paper and away from the observer. And both these bonds, which are shown by a normal line, are said to be in the plane of the paper. So this is the way to do the 3D representation of organic molecules. So thank you so much. So in the next video, I will be covering about the types of the covalent bonds, which are the sigma and the pi bonds. So thank you so much.